All right, recording's rolling. Today is Thursday, September 22nd, and we've got this Atwood Laboratory lined up. Now, I know yesterday Bell cut us off at an awkward time because I was halfway in the middle of solving this problem. So I do eventually want to go back and solve this with you guys. Reminder, you guys do know the solutions are posted to Google Classroom. I know they're pretty kind of faint. So anyway, but they are out there. This was number 19, and the solution has worked out. So if you were super curious and wanted to check your work and look ahead a little bit, then that is floating out there. But I'll take you guys over the rest of that solution another day. But I want to take today to do this Atwood Lab with you guys. Now, you guys have this printed page on your desk. So I've been trying to switch over and have you guys draw and write your own tables. I think that's more active on your part, and helps you learn stuff better. But we'll do an exception day. So I've got this pre-printed table for you guys. And also, we're not going to do a full AP style write-up with this, so just go ahead and write numbers in here. But remember, I demoed this for you guys. So you guys got some materials back in the lab desk. You guys got some of these pulleys. You guys got some string. You guys got a bunch of lab weights. And you can rig up a classic Atwood, where it's like a double elevator Atwood, where they both have.
Good morning, part of the interruption. At this time, teachers, please ensure that you've checked your testing retake list. There are 4 classrooms for the students for retake testing. So proctors will wait to start until 9 o'clock. So please check that list and send any students down. And just a reminder that all of 9th grade will go to the auditorium, and we will start announcing around 9:45 for them to be dismissed for a presentation in the auditorium. So please give that announcement at 9:45 for all freshmen to go to the auditorium for the presentation. Thank you.
You can also do this modified version where there's just one that's hanging down, which I showed you guys the free body diagrams for this yesterday. Remember that the weight of this one is providing the external force, which is driving the whole system to move. Okay? And the one up here is on a horizontal surface. So the weight of this one is balanced out by the normal force, but it does have inertia, which affects the motion. Here, I've blown up these pictures here. Let me give you guys some hints. It's for the double elevator. If you start out, you don't have to do it exactly this, but this will make it easier. If you start out with both of them like the same mass, like 200 grams, 200 grams, and you like tag an extra little mass here, like an extra 10 grams, this one will be a little bit more mass than this one. So if they're pretty close to each other, but a little bit different, then it'll accelerate kind of slowly. Right? So that helps just the mechanics of it, right? Another tidbit here. So when you switch over and do the horizontal one, if you tape a Hot Wheels car here, that will pretty well get rid of the friction, right? Like the free body diagram yesterday, I showed no friction here, right? And then, do you think if you if you like slow down the acceleration, it's easier to time it, right? And it works a little better. Do you guys think if you put a little tiny mass here and a big mass here, right, that will have it accelerate pretty slowly, right? Which will make it again easier to time. Okay. So take you guys through this table. I think you guys can probably figure this out, and ideally would figure this out from scratch yourselves. But you're allowed to know what free fall gravity is. Oh, look at that, 980 centimeters per second squared. Ooh, that's like 9.8 meters per second squared, isn't it? Okay. But we're doing centimeters because well, let's do centimeters today. Okay. You can record each of the masses. Then I'm going to have you guys do some calculations. Take the difference in the sum of the masses. Why? Hang on to that idea because I'll show you in a minute. Okay. Oh, no, it's absolute value. That means you just care about the positive difference, right? Okay. So I don't really care about clockwise, counterclockwise, right, today. Right. X, like how far does something move? That's like this X right here, right? So if these weights like start from rest and exchange places, right? You guys got some meter sticks back there. I bet you could. It's probably pretty close to 100 centimeters for the vertical one. Is probably good call, right? And the one that drops, well, those lab tables are a little bit short of 100 centimeters. Time. Now, you guys know this is the trickiest one in all your labs. It's going to be like using the stopwatch. You guys brought your cell phones today, right? Ooh, good. Right, glad you guys brought your cell phones. Okay, you guys get these stopwatches. Do 3, take an average. You guys know that AP specifically looking for that for one of your steps, right? Okay, and then you guys are going to calculate acceleration. Now, think about this. If you know if it starts from rest, you know how far it moved it in centimeters and how much time it takes. That's 3 kinematic values. Could you do x equals 1/2 at squared, rearrange it, and get acceleration based on everything else? And I did that expression for you up here, but you could do that from scratch yourself if you had to, right? Like if I didn't get that to you, you'd be able to figure that out, right? So you can calculate what the acceleration is. remember how acceleration is like a bridge between kinematic motion and dynamics? Because they both involve acceleration, right? Kinematic motion, like x tax BV, right? And then dynamics is like F equals ma, right? They both have an acceleration. So it's going to connect everything. Right? Now, what is the, so sometimes I say the acceleration of the system. Usually a better way to word that, what AP says is like, what's the downward acceleration of the heavier mass? Or what's the upward acceleration of the lighter mass? That's probably a technically better way to say that. There's a way you can approach this from a free body diagram point of view. And I started that on the PowerPoint yesterday, but I didn't quite finish that process. I just got started. So like, okay, I kind of see how that would start. Okay. But I'm gonna have you guys figure this out empirically using this lab data today, which is like a different path through the forest to also get to the answer. Okay. So the answer here, at the very, you guys see a box of bombs says A equals. Okay. Can you figure out a relationship? So what the acceleration is going to be regardless of the input masses. So you can put in any input mass 1 and mass 2. Right? You guys get that idea? So A is a function of free fall gravity, which is like a given value, right? And M1 and M2. Okay. And I'm helping you guys out with it. See where I say the starred columns? You guys see at the bottom some of these columns, there's an asterisk, like a star. Right. So this acceleration, which you can calculate using kinematic motion, as a function of, well, free fall gravity, which is a constant, and also the difference in sum of the masses. I'm sort of helping you guys piece a formula together. Tell you that there's some way you can multiply or divide these first 3 columns that should get you something pretty close to that last column. Okay, you guys kind of get that? Okay. Okay. And then when I take you guys through the actual solution using free body diagram method, hopefully you come up to about the same answer. Okay. When you guys switch over and do the modified Atwood version like this, well, I think you guys can figure that out. It's very, very similar story. Okay. What else do I want to tell you about this? How about this? Since we got a time constraint, you guys gonna set the pace today? Try to do this. Try to get at least 3 different combinations of masses on the double elevator and 3 combinations of masses on the single elevator on the modified. Okay. I think you should probably have time to do that. And if you do, then I bet my other classes will too. Okay. Right. And then don't worry about AP style write up. See if you guys can do 3 combinations here, 3 combinations here, get the solution. And then one last thing, hang on to this page because on the back I went ahead and printed the friction lab and we need to do this, but this is going to have to be a next week lab. So hang on to this page and then I'll eventually pick this up for you guys. All right. So go ahead, everything you need, back lab tables, and you guys can set the pace today and I'll walk around and help you guys out.